Hi everyone. So here are your notes for 1.1 points, lines, and planes. Now these three figures or objects that we are about to talk about are basically the building blocks of geometry. So let's go ahead and get started with the first description, and that is a point. All right, so a point is, as you may already know, it is quite simply, it's just a dot. Okay, you can think of it as a location, for example, a location on a map. Okay, and one thing to note about a point is that it has no dimension. In other words, even though we draw it as a dot, it's not wide, it's not thick, it's not tall, it's not short, it's not long, etc. Okay, it's simply just a point in existence. So, for our example, in order to draw it, we just draw a dot. And to name it, or what we should look for always, is the capital letter right by that dot or point. Okay, so I can have one there. I can have another one over here. I'm going to label this one as B. Okay. And then when we go to name these points, the kind of clear-cut way to name it is to write the word point and then to give the single capital letter. Okay, so point A. We can also use just the capital letter by itself. This is also an option, okay? Point B, but when you read it, we say point B. Okay? All right, and then so just to summarize or to make a general rule, we use a single capital letter to name our points. So that's a general rule. If we see a letter by a point, or a capital letter, I should say, by a point, that's what we're going to use to name it, okay? All right, moving on. The next figure, or next object we're going to talk about is a line. Now, many of you already know this, but let me just reiterate it. A line has arrows on both ends. Because it's signifying that it is infinitely long. Okay? And if something is infinitely long, we cannot measure it. Okay? But it does have a dimension. It has one dimension. Okay? In a way, you can think about that in terms of direction, right? It can go left and right, it can go up and down, but it has one dimension. All right, and then the last thing that what a line actually does is it connects 2 points. This is the purpose of a line, right? If we have 2 points in space, you can connect those 2 points with a line. So, if we go ahead and move into our drawing or our example of a line, we should probably first draw 2 points because that's what a line connects. So I have 2 points here. Make sure you give them names. I'm going to call this one C, call that one D. And then I'm going to just connect these 2 points with a line with arrows on the end. Again, this is to signify that it continues to grow forever and ever. All right. And then to name a line, there's actually several ways to name a line. The first way, very similar to point, is to just write the word line, followed by 2 points on that line. I only see C and D in this case, so I'm going to call it line CD. Another way to name it, and for this one, order doesn't matter, and so I could technically say DC and draw the little line symbol on top with arrows on the end. The final way to name a line is to look for a lowercase letter. You want to look for a single, maybe script, okay, or cursive. You might want to look for that script or cursive, lowercase cursive letter, because that is another way that we might name lines. But for this one, you do have to write the word line followed by that single lowercase letter. But again, just in general, we use 2 points on the line to name it. And yes, it has to be on the line, cannot be off the line. Okay, so now that we are done talking about lines, I would like to mention a word that has something to do with lines. Right? And that is this word right over here. It is collinear. Okay? So when we look at this word, there is a word in there that we should recognize. It's right here. That word line. Okay? And co, meaning together or with, tells us that, or sorry, same even, tells us that these are referring to, if we use the word collinear, this is referring to points on the same line. Okay. All right, so if we go ahead and take a look at or move into an example, let's draw a picture. Well, if we have points on the same line, then we should probably start by drawing a line. Okay, I'm going to add a couple points to this line. Let's go ahead and call that point E. There's a point there, call that one F, and I'm going to put one further on the end and call that one G. Okay. And I'm going to add one more point kind of off the line. I'm going to call that one H. Okay. All right, now taking a look at this line, this example that we have here, we can see that E, F, and G are all on line EG right here. And H is kind of floating in outer space. And so what we can say is points E, F, and G. And please make sure that you list. In other words, you use commas because we're going to get to a moment where we'll use multiple letters to name and we don't want to be confused. But points E, F, and G are collinear. Notice how I did not list point H because point H isn't on that same line. All right, moving on to our last building block for geometry, and that is a plane. Now, a few things to note about the plane. It is two-dimensional. If you think about a coordinate plane, you have two dimensions there. We have an X dimension and a Y dimension. Okay? Kind of like a surface, right? Like a tabletop area. And a plane is also infinite, but I'll say that it stretches. To infinity. All right, and a line connects two points while a plane connects 3 non-linear points. Okay. All right, so that word nonlinear is the exact opposite of collinear. So if collinear up here means same line, points on the same line, nonlinear means points that are not on the same line. So in order to draw that, we need to have points, 3 points specifically, that are not on the same line. So here's a point, Here's another point. I could technically connect these with a single line, but I need to add a third point that is not going to be on that same line. Let's go ahead and call this J, K, and L. And then in order to signify that this is a plane, I do need to add sides. Okay, something like this. All right, 4 sides. Now, keep in mind that I said that this plane stretches infinitely. So even though I draw borders around these 3 points, think about it like the ocean. You can continue to go past all 4 of these sides. And so the plane will continue to stretch forever and ever into infinity. All right, now we'll get into naming these planes. And the way we name the plane is 2 ways. First one, of course, being you just write the word plane, and we do need to use 3 points for this one. Those points are going to be on the plane. So we have J, K, and L. So plane J, K, and L. Another way you might see a plane being named is if there is an uppercase script letter, okay? Or maybe just an uppercase letter, but there's no point, right? If we take a look at the picture, R is over here by itself, but there are no points anywhere near it. And so we can say or name this plane, plane R. Okay. But the general rule for naming planes is to use 3 non-linear points. That's the general rule for naming any plane. All right, the final vocab for this list right here is coplanar. All right, now I'm hoping that from how I said it, the word co and planar, that should signify to you that this word means that you have points on the same plane. Okay, very similar to collinear when we're talking about points on the same line, right, up here. But for coplanar, we are specifically talking about the plane. So, as an example, I'm going to go ahead and draw a plane, a little bit more slanted than the last one, and I'm going to add a point on that plane. Now, here's where it gets tricky. I'm going to add a line that goes through this plane. I'm going to add a line that goes through this plane. So it's solid on top and then dotted on the bottom to show that this line passes through this plane, like a pencil going through a piece of paper. I'm going to add a couple more points, maybe just about 2, 3 right there. All right, this point, let's go ahead and name it P. This one is Q, R, and S. Now, if we're taking a look at the points, notice how point P is sitting on top of the line and it's not anywhere on this plane. So if I were to ask for coplanar points, we cannot name P because P is not on the plane. So if I were to say, give me 3 coplanar points, we can go ahead and write points, listing them out with commas, Q, R, and S. And we can say that these are coplanar. Okay. Again, notice how point P is not anywhere on this list because it's not on the plane. It's on the line, but the line is above the plane. It's not on it. Okay, moving straight into our first example. So, example 1, it says to use the figure to name each of the following. Okay, this is the figure, right? The picture, in other words. First item, they want us to name a line containing point A. So if I want a line containing point A, well, I got to figure out where point A is. Point A is right over here. Now, in order to name a line, I need to use 2 points. It doesn't matter which 2 points I use. I could use point C. I could even use point D if I so wished. So, several ways to name it. I can go ahead and say line AC with the symbol on top. I could even say line AD, like so. Or I don't even need to use A because all these points are on the same line. I could say line CD. All right. And then part B asks us to name a plane. Name a plane containing point C. So, in order to name the plane containing point C, I need to figure out where point C is first. So let me go ahead and circle it. It's right over here. And in order to name a plane, I need 3 non-linear points. As we are taking a look at this picture, A, B, and D are all collinear with point C because they all are on the same line. The only point that is not on this line in this picture is point E. And so when I name this plane, I have to use E in the name. After that, it doesn't matter which other 2 points I pick. I could say plane ECB. I could say plane ADE. Okay, I don't need to use C because C is in this plane. Or I could say plane N. Okay. Because we do see over here there is a uppercase script letter and it's not by any points, not labeling any points. All right, part C is asking us to name 2 points that are collinear. So collinear again means that we have points that are on the same plane. So taking a look, we only have 1 line to worry about and we have several points. So you just need to pick 2 out of these 4 points. We could say points A and B. You could even say points C and B, etc. And then the last problem over here, or the last part of this problem, asks us to name 2 points that are coplanar, but keep in mind they cannot be collinear. Again, that means that they cannot be on the same line. So if I want to name 2 points that are not on the same line, I need to use point E, which is currently not on line L or line CD, however you want to name it. So we got points E and C. You could also say points, I'll go and abbreviate, points A and E. Okay, there are several options here. You just need to make sure that you use point E. All right, so for this problem right here, go ahead and pause the video and give this a try on your own. Go ahead and check your answers over, okay? So the first one asks us for 2 names for line PQ. And so I have 2 options here. We can say line QP, right? Q and P are on the same line, so we can use those. You can also use the lowercase n up here. That is an option as well, okay? For plane R, there actually are more than just these few ways that I wrote out, but so long as you use the point V, you are good to go because point V is the only one that is not collinear with any of these on line M. For part B, we need 3 points that are collinear. The only 3 that exist are going to be these 3 points right here, S, P, and T. And the last one asks for 4 points that are coplanar. So we have only 4 points on this entire plane, and that is point V, point S, point P, and point T. Okay, just a couple more vocab words to worry about. The first one is a segment. Now, a segment is a part of a line. And a segment has two endpoints. I will abbreviate PTS for points. And so we have 2 points. So let me go and draw 2 points. Name these points. I will go and name this A, B. And then in order to draw in my segment, I simply just connect these 2 points with a line. Now, the difference here between a line and a segment is that a segment is measurable. And that has to do with the fact that a segment stops, right? There are 2 endpoints. We know and we can measure how long this segment is. Very different from a line, which goes to infinity. All right, so as far as the name goes, the name is almost similar, but here's where we have to be careful. If I had an extra point on this segment, let me go ahead and call that point C. If I want to name the entire segment from beginning to end, I have to use the 2 endpoints. And the endpoints here are A and B. And then I can put a bar on top with no arrows. This is the short way to write segment. You can also write out the word segment and then just name it. Give me the 2 endpoints, BA, AB, same thing. But notice how I am not using C because C is not the endpoint of the whole segment here. Okay. So some general rules. In order to name a segment, you use your 2 endpoints. Okay, so moving on to our next vocab, and that is a ray. Now, you can think of a ray very similar to sunlight rays, right? We've seen this, we've done this before in elementary school, but these are sunlight rays. And we know that these rays come from the sun itself. So these rays travel outward. Rays in geometry do very much the same thing. And here's what they look like. They have one endpoint. We call it an endpoint because that's where the segment ends, right? And on the other side, it goes to infinity. In one direction. Unlike a line goes into infinity in 2 directions, but a ray only does that in 1 direction. So, in order to draw this, we of course have to start with our endpoint. So let's make ourselves a point. Let's go ahead and call this point D. And then it goes to infinity in 1 direction. So we need to draw a line with an arrow at the end to signify infinity. And because a ray is a part of a line, we have to use 2 points to name a ray, just like we use 2 points to name a segment. I'm going to go ahead and call this point E. All right, and then here's where we have to be careful in naming rays. With segments and lines, it doesn't matter, but with rays, because there is 1 direction, direction does matter. And so if I'm looking at my ray, it starts at point D. I know we call point D an endpoint, but that's really where this ray starts, and it goes this way into infinity. And so we always have to use the end point when we begin naming. So I'm going to go ahead and say this is point D, and then it goes to infinity in the direction of E. And then we will draw a little symbol on top. This is how we write ray. Or you can, of course, as always, just write the word ray and then give me the points in the correct order. In this case, D, because D is the endpoint, and then it goes to E. All right. Now we have what's also called opposite rays. And here's a longer description for this one. If a point lies on a line and in between 2 points. Okay. So let me go ahead and pause there and write what this description is saying, right? So I have a point, so let's start with that. Here is a point. Draw it somewhere in the blank space. I'm going to go ahead and call this point F, okay? And it's on a line. So if it's on a line, I need to add my line that goes through this point. And it's also in between 2 points. So we gotta make sure that F lies between 2 other points. Go ahead and call this point G. And call this point H. There we go. All right, now continuing on with the description. If this is the case, then we will have opposite rays. Okay. All right, so taking a look at the picture, we can see that we have a ray that starts at F and goes towards G. We also have another ray that starts at F but goes towards point H. And they form together a straight line, and that's what we always want to look for. If they do not form a single straight line, they are not opposite rays. So that's where we have to be careful. Just because you have 2 rays, if they don't form this straight line, they are not opposite rays. But we can go ahead and name these 2 right here because they are opposite rays. And keep in mind, again, direction matters. So both of these rays start at F, so I'm going to say F to G is 1 ray, and F to H is another way, right? Ray FG and ray FH. These are opposite rays. All right, so we're going to go ahead and use these vocab words to finish up our last example. Okay, so taking a look at example 2 right here. It's all about segments, rays, and opposite rays. So in the problem, it says to use the figure, right, this picture over here, to answer the following questions. They want us to give another name for segment GH. And the reason why this is segment is because there are no arrows on either ends. That's how I know this is segment. So we need to take a look at the picture and figure out, okay, here's H, here's G, so here's the segment HG, and where they cross is point J. Let's go ahead and let's make ourselves a point there, just to remind us. So if I want to name the segment GH, it has to be the whole segment from here to here. So I cannot use J because J is in the middle, and our segment begins and ends at G or H. So we can write down, of course, the word segment and name it HG, right? We can go the opposite way, that's fine. There's no direction for segments. Or we can write HG with the bar on top. In part B is asking to name all rays with the endpoint J. So if I want to name all rays, with endpoint J, I need to locate point J. There it is. All right, and then as we can see here, there are 4 rays. J, we can start at J and go to E. Start from J, go to G. Start from J, go to F. And start from J and go to H. So those are the 4 rays that we're going to name. So we have ray JH. We have ray JF. We have ray JG. And we also have ray, J, E. Those are our 4 rays with endpoints J. Now, the second part of this problem asks us which pairs are opposite rays. So out of the 4 that we listed, which ones are opposite rays? So if we are taking a look at the picture, keep in mind again that in order to be opposite rays, you have to form a straight line. So if you pair up JH and JF, notice here that there's actually a little corner, right? If we were to drive along H or JH and then drive onto JF, we would have to turn. And so because that happens, these are not opposite rays. So if I want to choose JF, right? JF, I will choose to be one of my pairs. JF. I have to look and see, well, which ray helps make a straight line? And that's literally on the opposite side. So we would pair JF with JE. Okay. And that doesn't leave us a whole lot of other choices for JH. It has to be paired with JG. All right, so that is all on rays, segments, and endpoints. All right, so at this moment, go ahead and pause the video and give this a try on your own. Okay, go ahead and check your answer over. This one is asking you to use the figure to answer these questions. The first one is just asking for another name for segment KL. Well, segment KL is right here. Keep in mind that you cannot use P because P is in the middle. We have to use our endpoints. For part B, it's asking, are ray KP and ray PK the same ray? Now, your explanations might be different from mine, and that's okay. But one possible explanation is to tell me that, oh, well, ray KP means that you start at K and then goes towards P. But ray PK means that you start at P and goes towards K. That's why these are technically not the same rays, because you're talking about 2 different directions here. Okay, and then for the last one is asking, are ray NP and ray NM the same ray? Well, both of these, as we can see from the names, start at endpoint N, which is right over here. And then NP goes from N towards P, which is in this direction here. And NM starts at N and it goes towards M. And as we can see from the picture, if we go from N to M, we actually pass by point P on the way, which is why the answer here is yes. Both rays start at N and then they go towards point M. All right, so one last thing to note. And that has to do with intersections. Okay. The intersection is a set of points, or it could be one point. But the idea is that it's where your figures or your pictures overlap, okay, or have in common. That's what we're looking for. So in the case of 2 lines, you've done this in algebra before, when we have 2 lines that intersect, they intersect at a single point. Okay? But when we have planes, so imagine two pieces of paper that cut through each other. Where they intersect is actually a line. It's not just a single point. That's why you can see here it says line Q. All right. Thanks so much for watching.